final answer, it will become more simple to see. Then I simplify the equation given. First, I divide the GS in both numerator and denominator. Then the numerator will become 1 and denominator will become 1 over GS plus NS. Then I substitute the GS and NS in this equation. Until this, I will multiply the s squared plus 5s plus 2 to s to 10s. Finally, we will get it afterwards.
This is my what? Okay, hi. This is my record session where my question was given for me is number 2. Consider an electric circuit with a resistance R1, R2, and R3. So the question was, I already put out the question here, where power P dissipated by R1, R2 and R3. The given formula is P equal to I2 R1 plus I1 squared R2 and so on. As you can see here, the formula is that when you are calculating power, the formula is P equal to I squared R. So bear in mind that R1, R2, R3 and I, the current, is a positive constant. Okay, in my solution, firstly from this equation you have to differentiate it. So I already did my differentiation where 2I1 R1 to I1 R2 plus 2I1 minus I minus I1 times I1 minus 1 R3. When you with this part, you can just put a simple calculation or even arrangement. You can have this part where 2I1 is times R1 plus R2 plus R3 minus 2I R3, where this is the I that has been calculated, that we have calculated just now. So we are assuming that differentiate from differentiate of dp over di is equal to 0. So we can conclude that here are the formula that we have been doing just now. So we have to eliminate the number here so that we can find I1. So in here we have to divide by 2 so that we can cancel these 2, and then from here you have to rearrange it so that I is equal to R3 over R1 plus R2 plus R3 times I. So from here you can find it how to get I1, where you have put this calculation here over here. So I R3 equal to I1 R1 plus R2 plus R3. So you can get here. Alright, for my from here you have to differentiate it one more time so that d squared P over di squared equal from the previous question, where we have to find that either this value of equation is a minimum value for power. So we have to differentiate one more time I1. So here we can find that this is I1, this is don't have an I1, so we can conclude that this is 0. So when this is I1, you have find out that 2 R1 plus R2 plus R3. So from this equation, we have known that d2 squared over di1 squared is more than 0. So the graph should be in concave upward. So hence P has a minimum value at I1 equal to R over R1 plus R2 R3 times I. So that's for my question number 2A. Then that's all. I will continue with my question 2B. Okay, for 2B, I resume with my previous question, where B, the information is given for me from me was given by V equal to IR equal I1 times R1 plus R2. So for minimum power dissipated, we have to show that R is equal to R1 plus R2 times R3 over R1 plus R2 plus R3. Okay, since power is a minimum at I equal to R3 over R1 plus R2 R3 I. So from the given formulas, we can conclude that I1 R1 is equal to, this is from here, where the given formula is I1 times R1 plus R2. So this is here and is multiplied by R1 plus R2. So the I is, we can eliminate I from both sides. So this will be at R equal to, we multiply R1 plus R2, 1 plus R2 R3 over R1 plus R2 plus R3. So we have shown that this is what the question asked us. So here are what has been shown. So that's all for my question 2B.
For question 3, an AC current I is given by I equal to 3 cos omega t plus 4 sin omega t. We need to find the amplitude and sketch one complete cycle for omega equal to 100, omega equal to 100 pi radian per second, and using simulation and electronic tools. I would like to use the combination of A cos plus B sin theta to solve this question. Write as A cos theta plus B sin theta equivalent to R cos theta plus alpha. And then in this question, I equal to 3 cos theta 3 cos omega t plus 4 sin omega t. We can write like this, that I equal to 3 cos omega t plus 4 sin omega t equivalent to R cos omega t minus alpha. Then will be R cos omega t cos alpha plus sin omega t sin alpha. How this will become like this? It is used by the formula cos A minus B equal to cos A cos B plus sin A sin B. Then this equation will become like this. Finally, I multiply inside the equation will become R cos omega t cos alpha plus R sin omega t sin alpha. Equating coefficient of cos omega t and sin omega t, we can get the equation 3 equal to r cos alpha from equation 1 and 4 equal to r sin alpha from equation 2. In this equation, when equation 1 square plus equation 2 square will become r square cos square alpha plus sin square alpha 9 equal to 9 plus 16. So I square equal to 25, r equal to plus minus 5. When r bigger than 0, r will become 5. Equation 1 divide equation 2 square. No. Equation 1 divide 2 tangent alpha will equal to 4 over 3. Alpha will become 0.2995. Finally, I equal to 3 cos omega t plus 4 sin omega t will equivalent to 5 cos omega t minus 0.2955. Omega is equal to 100 pi radians per second. So I will become 5 plus 100 pi t minus 0.2955. 5 will become our aperture. And the graph will become like a curve. The last step for this question, I need to sketch the graph using simulation and electronic tools. I find online tools to sketch this graph. First, I need to enter to www.inmesh.com and I need to change the function equation. This many will become like this, but we need a complete cycle only, so I would like to change the minimum as value and maximum as value. and the interval also need to change. So I can get this.
So the questions asked so the first question asks to show that dv dx equal to kx bracket 2 ln 1 over x minus 1 from the questions v, which is proportional to x squared ln 1 over x. So v, we can see v is proportional to x squared ln 1 over x. So to eliminate this, we need to put a constant, which is k. v equal to kx squared ln 1 over x. So from these questions, we can use power rule, which is u v prime plus v u prime. U is equal to kx squared, so the u prime is 2kx, differentiate, and v equals to ln 1 over x, and the differentiations of v is negative 1 over x. So we can put it according to the formula. So the u is kx squared, v prime is negative 1 over x plus ln 1 over x, which is v, and u prime is 2kx. So we simplify this to negative kx plus ln 1 over x 2kx, then kx 2 ln 1 over x minus 1. So the equation has been proved based on the questions. So the second questions asked to distinguish between these stationary values and show that the speed is greatest when x equal to 1 over set e. So we assume that when dv over dx equal to 0, so 0 equal to kx 2 ln negative 1 over 1 over x minus 1. So when x equal to 0, x equal to 0 is invalid because it does not have stationary value. Okay, so we need to assume that 0 is equal to 2 ln 1 over x minus 1. So we put 1 equal to 2 ln 1 over x. So 1 over 2 equal to ln 1 over x. So we put e at the both sides. So e 1 over power of 1 over 2 equal to e ln 1 over x. So e ln is equal to, we eliminate it and become in turn to 1. So 1 over x is equal to e 1 power of e power of 2. So x equal to 1 over e power of 1 over 2, and also can be written as e set e. So this value is valid because it is a stationary value. Okay, so when x equal to 1 over set e, so from the questions, v equal to kx squared ln 1 over x. So substitute x with 1 over set E. So V equal to K 1 over set E ln 1 over 1 over set E. Okay, squared, sorry. Kx squared, so we need to put squared. Then simplify it. So K K over E, so power inside it, and ln set E. Then K over E ln E 1 over 2. We put this power 1 over 2 in front of it, and K over E 1 over 2 ln E. So ln E is equal to 1. So K over E times with 1 over 2. Okay. So we get K over 2E. So V is equal to K over 2E. So we can conclude that X, which is 1 over set E, and V is K over 2E, is a turning point. Okay. So then we need to differentiate for the second time, which is, so I just write the same value, which is dv over dx is equal to kx squared 2 ln 1 over x minus 1. So to differentiate, we also use the same rule, which is power rule. U v prime plus v u prime. So the u is kx squared and v is 2 ln 1 over x. So u is equal to kx squared. So u prime is 2 kx and v is 2 ln 1 over x minus 1. So the v prime is, so for the v prime is negative 1 over x. So we put it based on the rule, d squared v over dx squared is equal to 2 kx u, and v prime is 1 over x plus 2 ln 1 over x minus 1 times with 2 kx. So simplify the equations, which is negative 2k plus 2k ln 1 over x minus k. Okay, so simplify it again. 2k ln 1 over x minus 3k. Okay, so when x equal to 1 over set E, so substitute x, which same with 1 over set E. So 2k ln 1 over 1 over set E minus 3k. So minus 3k, so 2k ln set E, same with set E minus 3k. So set E, so 2k 1 over set k 1 over 2 minus 3k. So 2k, so times 2, so k minus 3k, then is equal to negative 2k. So the second differentiations of dv dx is equal to negative 2k. So from this answer, we can conclude that k, which is constant, k is a constant, which is a positive value, So we can conclude that second derivations of dv dx is more than 0, so it is a maximum point. It is a maximum point. Okay, so that's all. Okay, this is for the question 5. So the 5a questions, it asks to find f prime 1 from the equation of fx equal to x e power of x. So to solve this question, we need to find the first differentiations of x, which is we use the product rule u and v. So x u equal to x and u prime equal to 1, and v equal to ex. Differentiation of v prime is ex also. So the product rule is u v prime plus v u prime. So u, we just put it as x, v prime ex plus v ex, and u prime is 1. So the differentiation of fx is x ex plus e power of x. So then we need to find the differentiation of x, which is 1. So x is 1, e power of 1 plus e power of 1. So e power of 1 plus e power of 1 is equal to 2e, or equal to 2.7183. That's the questions of J5. For the questions 5b, the questions ask to find the value using central difference approximations and forward difference approximation, then compare the value using this formula and the forward formula. So the equations of the central difference approximation is fx equal to fx plus h minus fx minus h over 2h. So this when x equal to 1, so we just put the 1 to replace the x, 1 plus h minus f, 1 minus h over 2h. So the first number of h is 0.01, so we just substitute the h. So 1 plus 0.01, 1.01 minus f, 1.99. So the value of f 1.01 we can see from the table provided, which is 2.7739 minus 2.9943 over 2 times 0.09. So the answer we get 5.44. Then h equal to 0.02. So the value of f 1.02 minus f 0.98 is 2.8287 minus 2.6112 over 0.04, which if the answer is 5.43 0.75. Okay, then the value of h which is h equal to 0.03. So f prime 1 equal to same formula, 2.8851 minus 2.5588 over 2 times 0.03. So the answer is 5.4383. And the last edge is 0.03. So the 0.04, sorry. So the number of f 1.04 is minus f 1.94 at 0.94 is equal to 96, sorry, 96. So 2 times 0.04. So f1.04 is equal to 2.9424 minus 2.5072 divided by 2 times 0.04. So the answer is 5.44. So this is the question using the central difference. Then the question asks to use the forward difference approximation. So the equation is f prime x equal to fx plus h minus fx over h. So x equal to 1, we just place the value of x, place the x equal to 1 minus f1 over h. So same the value of h, which is 0.01. So f prime 1 equal to f 1.01 minus f1 over 0.01. So the value of f 1.01 is 2.7731 minus value of f1 is 2.7183 over 0.01. So the answer is 5.48. Okay, answer. Then for the h equal to 0.02, f prime 1 equal to f 1.02 minus f1 over 0.02. So the value of f 1.1.02 is 2.8287 minus 2.7183 over 0.02. So the answer is 5.52. For h equal to 0.03, f prime 1 equal to f 1.03 minus f1 over 0.03. So the value of f 1.03 is 2.8851 minus 2.7183 over 0.03. So the answer is 5.56. The last value is h 0.04. So f prime 1 equal to f 1.04 minus f prime, which the value is 2.9424 minus 2.7183 over 0.04 5.60. Okay, so for this all answers which is use the central difference approximations and forward difference approximations, we will get the difference answer. So we can conclude that using the, so we can collect all the values for the central difference approximation which is the value is 5.44, 5.4375, 5.4383, 5.44. This is for the central, and for the forward, the value that we get is 5.48. 0.02 is 5.52, 5.56, and 5.60. Okay, we can see the difference between the answer using the central difference equations and the forward equations. So the real answer is f prime 1 is equal to 5.44. So for the central difference, we get the least difference compared to the forward equation. So we can conclude that central difference has the nearest value to the 5.54 compared to the forward equations. That's all.
Okay, this is our final question from number 6, the question number 6 from this assignment. Okay, here we have two information given to us, that is F1 for positive period and -1 for negative. So here we have found out that the volume, this one is 1 and -1 for y axis. So in this x axis, we have to find out 1 over 2, 1, 1 over 2. Okay, for this period of time, we have found out that this, and from here to here. Okay. Wait. Okay. Firstly, sketch. The question is sketch its graph and obtain the graph of gx equal to what is gx. Okay, gx is equal to integrate x0 ft dt. Okay, we are using when 0 is less than or equal to x less than 1 over 2, fx is equal to integrate x0 ft dt. So here we can find that fx0 1 dt. So we are using a positive value here, and is equal to t infinite 0. Sorry, this is infinite 0. So the question will be, the answer will be infinite. So when 1 is equal to x 3 over 2 is equal to fx equal infinite to 0 ft dt. So this we have to use when 1 over 2 is less or equal to x and 1. Okay, we are using this formula. So fx is equal to integrate infinite to 0 ft dt. So the equation, this part we have to use from integrate 1 over 2 to 0, 1 over 2 to 0 ft dt plus integrate infinite to 1. So when infinite to 1 is also ft dt. So here we can use that infinite 1 over 2 0 plus infinite square root integrate to 1 over 2. Oh, sorry, this one is 1 over 2. Okay, so this is minus 1 dt. Okay, so here we have 1 over 2 after integral of this part, 1 over 2 plus minus integrate minus infinite minus 1 over 2. Okay, so it's equal to 1 minus infinite. So this is the final answer for this range. So next we have we will using 1 till from 1 till 3 over 2. So in this part we have to use integrate 1 over 2 0, okay, to ft plus integrate 1 over 2 ft dt. This is also dt. Okay, plus integrate infinite 1 ft dt. Okay, next we can find that 1 over 2 plus 1 minus 1 minus 1 over 2 plus infinite to 1 dt. This part we have been we using the previous one, so you can find that infinite minus 1. Okay, so next range we will be using when the next range will be when 3 over 2, so x is equal to less than 2, fx equal integrate infinite 0 ft dt. So here we have to find that integrate 1 over 2 0 ft dt plus integrate 1 over 2 ft dt plus integrate 3 over 2 1 ft dt plus 2 infinite 2 over 3 over 2 1 dt. Okay, this part will be more than 2, more or equal to 2. So here we can find that 0 plus 3 over 2 minus 1 minus 1 minus 1 plus minus x minus 3 over 2. So we will find that this is 2 minus infinite. Sorry, this is infinite. Okay. From all this information that we have calculated, we will use Microsoft Excel to find out what is the graph of this range by using this range. So yeah, I will show you the graph here. From this answer that the range we have been using was shown to be a positive integer, right? There is no negative integer in any of the range that we have been using. So I already done my range. So this is the report graph that has been shown. So we have concluded that 2 is proportional to that you have shown here. This all of, so this is the question 3, positive portion of x-axis. So here what we have been using. So sorry, I would like to change the color of the background first. Okay, so from here we find that 0 is equal to 0, like shown in the graph here. So when 0.5, we have concluded that the answer is 0.5 also. So you can see here the range of the graph. Okay, next is when 1 is the x is equal to 1, we have found out that this is 0 for the axis. So and so on. So if, for example, we have here is 2.5, it will shown to be 0.5. So you can use the insert graph. So here you can insert a line graph. Can use any of this graph. Sorry, wait. So you can use that any of that graph, so you can find out this formula. So this is the positive portion of the x-axis. Okay, right now we will calculate the negative portion of x-axis. Okay, so we will using when a range of when minus 1 over 2 is less or equal to x or more than 0. Okay, f x is equal to integrate 0 to infinite ft dt. So from the previous part, we know that in the negative integer, we know that 0 infinite is minus 1 dt. So when we we integrate this part, we got the value will be infinite. So next we are using this range to calculate when minus 1 is less or equal to x more than minus 2. So fx is equal to integrate 0 to infinite ft dt. Okay, so we are using this range, so the infinite will be 0 minus 1 over 2 ft dt plus integrate minus 1 over 2 infinite ft dt. Okay, so here are the infinite number of 0 to 1 over 2 plus negative 1 over 2 infinite 1 dt. So sorry, so the formula will, after we integrate this part, we can get 0 minus 1 over 2 minus 1 over 2 minus infinite. So you conclude that 1 is minus than infinite. So with this information, we have found out that what is the range of this this equation for negative portion of the x-axis. So I will continue the slide with Excel. So this is the negative portion of this equation. So here the same also with the previous portion, where 0 is equal to 0, then when minus 0.5 we can get 0.5. So yeah, that's all for my final question for this assignment. That's all. Thank you.